Okay, here we are again. All right, so last time we had just basically started chapter 14, our discussion about production and cost. But before we take a look at that, there's a few videos here that I want to show you. There's three here that I was supposed to show you in chapter 3, but somehow I forgot about them. But I still would like you to see them because they're very good discussions about the production of possibilities frontier, which will still continue to be helpful throughout the rest of the course. So we'll take a look at these first. And then I have some more videos for chapter 14, which we can alternate with the new material. So I'd like to begin today by looking at a three-part series on the production possibilities frontier that, obviously we should have seen it a little sooner, but it's still worth our while watching it because it's a very good series. And so I think you'll find it very useful and interesting. All right, so why don't we begin with this one? First, let me send it to you in the chat box, and then we'll check it out. All right, here we go. All right, is everyone done watching it? Good, yeah. So I think you'll see what I mean. They did a very nice job of that. I didn't realize until the end that it was actually produced by the St. Louis Fed. So the Federal Reserve System does excellent work with their resources for education, and so this is a good example of that. So anyway, so I don't want to leave you hanging in the dark here. Let's take a look at part two and see what comes next. All right, hold on. All right, let's check it out. All right. Is everyone done? Very good. All right. So there's another part. Hold on one second. All right. Here it is. Our final lesson focuses. All right, we all done? Well, I don't know about you, but I thought they did a very good job with that. It was visually very easy to follow what they were saying, but it was also kind of fun the way they set it up. Right down to the smallest details. Did you notice that the widget and the gadget workers always had the same colors as, like they did everything just right. It really worked out well, I thought. So, but anyway, so now that was, of course, left over from another chapter, but I didn't want to miss these because I thought they were so well done. But we do now have a video which is directly related to what we were doing the other day, and that would be our discussion about diminishing returns and the production function. So we'll watch that first, then we'll go back to the material for a while, and if we have time, there's a couple more videos here that we could watch, but not until we've covered that material. So we'll watch this next video first. We'll go back to the notes for a while, and then if we have time, we'll come back to these last two videos. All right. So they may not be as much fun as the one we just watched, but they're very important. So let's check these out. All right, here we go. All right, so I think that pretty well covered a large amount of what we just had been doing. And then he added one more thing, which we hadn't quite gotten to yet, but we will right now. And that would be the marginal product, which is a very important concept in microeconomics. And so first, let's go back and quickly review our example, which is surprisingly similar to his example, except we have beer and he has pizza. Okay, so the idea here, though, is that in any situation where we're in the short run, we assume that only one factor of production is variable, and typically we assume that that would be labor, which makes sense because obviously it's quicker and easier to hire workers than it is to acquire land and capital. So what we would like to know is if we keep hiring more workers, what happens to our output? All right. And so, yes, like you said, too, there's no specific time frame here. That actually depends on the industry. In some industries, the short run might be a period of weeks, and in some, it could be a period of several years. But all that matters is that we're assuming that we're in the short run. So therefore, all we can do is hire more workers. If we want more output, we have to hire more workers. The problem with that, of course, is that as we've seen, the more people we hire with the same resources, the less extra output we get from each extra worker. So for example, here we start with no workers and no output. When we hired the first worker, we gained three gallons. The next worker adds 5. Okay, then the third worker adds 4. Ooh, sorry. And then the next worker brings us only 2 more gallons. Now here we're breaking even, and then finally we're actually losing 2. And again, like I like the analogy of the hands on the keyboard. At first, that second hand really makes a huge difference, but the third and the fourth hands are not helping very much at all. In fact, they're probably getting in the way. And so this is exactly what's happening here. We've only got so much equipment. There's only so much room. So no matter how productive the workers are, they can only produce so much because they just simply don't have the resources that they need to do their jobs. Now, of course, in the long run, that would not be a problem. If the company sees this happening, then they would start acquiring either more equipment, or they could increase the size of the building that they're working in, or some of both, and their productivity would continue to rise. But in the short run, this is what we would expect to see. Then we combine these into a single graph called the total product of labor. And so in the video, they showed how to look at this in sections. The first 2 bring us the most increase in output. So we'll make a separate region here. I thought that was kind of a nice idea to break it up into regions like this. Then we reach the point where the curve maxes out. Let's put that at here. And then after that, it goes down. So in other words, here, output increases at an increasing rate. It doesn't last for very long, unfortunately. And then in the next region, output is still increasing, but at a decreasing rate. Oh, God's sake. And then out past this point, output actually decreases. And once it starts decreasing, it never turns back up again. That's it. Okay, so that kind of gives us a sense of how many workers we're going to hire. Ultimately, that comes down to the cost of the beer versus, or the price at which we can sell the beer versus the salaries. But we do know for sure that we're not going to want to go past 4 workers for sure, because after that, the 5th worker brings us nothing. The 6th worker brings us minus 2 units. So we'll pick something in here in this region. We can't have 0 either because that means we have no beer. So we'll pick something in this region, and the one we pick will ultimately depend on how much can we sell the beer for versus the wages of these workers, which presumably are all the same. Okay. Anyway, so what do we also need to know now? By the way, we also noticed that this was given, I think somewhere back here we mentioned the name of this situation. It's called the law of, well, if we didn't have it here, I'll sneak it in here right now. It has two possible names that are equivalent to each other. All right, so this, the total product curve illustrates what we call either the law of diminishing returns, or sometimes it's called the law of diminishing marginal returns. Now, in economics, the word marginal, has a very specific meaning. It's very important, especially in microeconomics. Marginal means, for any situation, marginal refers to the change in a variable that results from a small change in another variable. So in other words, what does that mean? Let me just show you a few examples of this. For example, the marginal product, which we'll be addressing in a minute, refers to the change in output resulting from hiring one more worker. Okay, we're using one more unit of labor, and we want to know how much extra output are we actually receiving from that last worker. So we'll see this quite a few times in the rest of the course, this concept of marginal. It can be used in a lot of different areas, but here we're specifically thinking about what we call the marginal product. And again, all that means is the change in the output that we get, not from all of the workers, but the last one that we hired. So in other words, if I hire one more worker, I need to know how much extra output I'm getting before I decide whether or not to hire that worker. Okay, that's what matters. How much extra output am I getting from that last worker? If it's not enough to justify the salary, then I won't hire that worker. All right, now we're going to introduce a few new concepts here that involve quite a bit of calculations, and it'll also result in a series of new graphs that we haven't seen before. So we're going to start by introducing what we will call the average product, or the average product of labor. Now, you can see the way it's written here. TP, remember, is total product. L is the quantity of labor that we're using. Okay, each worker we'll assume is a unit of labor. And AP, of course, stands for average product, but if you notice, there's a subscript here. That little L tells me that I'm specifically referring to the average product of labor, because I can also have an average product for all my resources. I can have an average product of capital, for example, and I can have an average product of land. But here I'm specifically interested in the average product of labor. And of course, everybody knows what an average is. It specifically means if I take the total output that I'm producing and divide by the number of workers, that I want to know what is the average that each one is producing. Okay, that's an important idea because it will help us analyze what would be the optimum amount of this product to produce. And of course, we're assuming that all these businesses that we're analyzing are profit-making businesses whose job is to maximize their profits. And they can't do that unless they understand how much each extra unit of labor they hire is contributing to their bottom line. Right, that's ultimately what they're after. If I hire more workers, how much will it bring to me? Or at the moment, given the labor that I have, on average, how much are they producing for me? All right, now, closely related to that is the concept that we were just looking at, which is marginal product or marginal product of labor in this case. This one's a little bit trickier because it represents changes, not just the absolute values or levels, but changes. So we're going to illustrate that with this equation. And what's different now is that suddenly we've got this little delta here. As you recall, delta is a Greek letter that is used to represent change. So in the numerator, I have the change in total product. And down here, I have the change in labor. So in other words, again, this is telling me how much extra output I'm getting from hiring one more worker. And of course, MP stands for marginal product. And here, this tells me that I'm specifically referring to labor. All right, so this will prove to be one of the most important concepts in all of economics. Just like the law of diminishing returns, the marginal product, or marginal anything for that matter, is an extremely important concept. We'll see it used over and over again, and we can use it in business to determine what should be the optimal amount of inputs to hire and the optimal amount of output to produce. In fact, let me make a note of that. That's so important. I'm going to sneak that in here as a separate slide. Marginal concepts can be used in many areas. They can, for example, they can be used by a profit-seeking organization to determine how much of each resource to hire and how much output to produce. So that's why this is so important. This is how we do it. We make our decisions based on marginal concepts, and we'll get more deeply into that as we go along. But I just want to see where this is going. So they can be used in many areas. In particular, they can help us understand how much of each resource to hire and how much to produce. Of course, with the understanding that our goal is to maximize our profits. That's what this is all about. Okay, now what we're going to do is look at an example where we get to do a lot of calculations. After you've done a few of them, you'll see it's pretty straightforward, but our job is to really ultimately understand what this information is telling us. All right, so here we go. Now we're going to take our microbreweries data, and we're going to actually go through and do all the calculations. Now, let's start with the average product of labor. Now, clearly here, this is undefined because we can't have division by 0, as you know. So let's look at the first row after that. I'm producing 3 gallons of beer with 1 worker. So all I had to do is calculate 3 divided by 1 to come up with the average product. Okay, what about here? With 2 workers, I have 8 units or 8 gallons being produced by 2 workers. They were bringing me 4 units or gallons each on average. Now look at this one. I've got 12 gallons being produced by 3 workers. And that, of course, is also equal to 4. When I move up to the 4th worker, I have 14 gallons being produced by 4 workers. 14 over 4 equals 3.5. And then, ooh, look at this. After the 5th worker, I still only have 14 gallons, which drops the average down to 2.8. And then finally, with this last worker, yeah, look at that. I've lost 2 units, so my average drops all the way down to 2. So the average is really simple. If you notice too, at first the average rises it reaches a maximum and then it falls. Okay, so this is always going to be the pattern, and this is the direct consequence of the law of diminishing returns. In other words, because of the pattern of increases over here in the second column, the average product as a result will rise initially, then it'll hit a maximum value, and then it starts to fall off. Although it will not actually be negative, it will rise, it'll peak out, and then it will fall. So if you wanted to visualize what a graph of the average product would look like, the average product would be here, the labor would be here, and you would end up with something like this, sort of a big, well, maybe like an upside down U, I suppose. This would be in gallons per worker, and L is the number of workers. Now, this may not be a perfect illustration of this. All that matters is that it goes up and then it goes down. And once it goes down, it never turns back up again. All right, so that's roughly how APL works. What about marginal product? This is the one that's a little bit trickier. So let's go back and take a look at it. Now, in this case, the calculations will be very simple. I'll tell you why, because what we're trying to do is calculate the change in total product over the change in labor as we move from one level to the next. Now, initially, again, we have, this is undefined. When we hire the first worker, okay, actually, let me erase some of this stuff. The key detail here is that when I move from this level to this level, delta L equals 1. When I move from this level to this level, delta TP equals 3. Therefore, this equals 3. And that tells me that I get 3 extra gallons from that first worker. Aha, you see, now when we go from this level to this level, because of the way the chart is set up, it's still delta L equals 1. But over here, on the other hand, the total product and change in total product is 5, because we went from 3 to 5. So the ratio of 5 to 1 is 5. Okay. Now we go down to the next level. Delta L is once again 1, but now delta TP is 4. Okay, so you can see already the marginal product peaked out at 5. It is now starting to fall. So again, let's go to the next level. The change in labor is 1. The change in total product this time is just 2. And that leaves me with a marginal product of 2. In other words, that fourth worker brought me 2 extra gallons of beer. Now, when we go to the next level, still delta L continues to be 1, but look at this, TP, delta TP is 0. That was it. No more extra beer came our way here. So we have a marginal product of 0. Again, it's not the worker's fault. There's just no room for them to work. And then finally, when we had that 6th worker, delta TP is actually negative 2. So we end up with a marginal product that's negative. This is obviously a bad sign. That means we're actually making ourselves worse off by hiring the 6th worker. Okay, so that was the end of that. Now, I'd like to show you what the graph of the marginal product curve looks like, and then I'd like to bring them together. In fact, that we should probably do that right away because it's easier to understand them when we can see them, oops, let me leave that there for a minute, when we see them together, because there's an important way in which they're related to each other. Very important. Now, you did see, by the way, some of this in the video, so it should not look too unfamiliar. All right, so let's see what this looks like. Okay, so the calculations, as you can see, are really not that difficult, especially when the quantity of labor changes by 1 each time. But the understanding of the curves is what we really need to focus on, and what are they actually telling us? All right, here we go. Let's try to bring these two together. So typically what happens, up here we'll have both average product and marginal product. Here we'll have labor. Let's try this. Let's do 2 different colors. All right, purple will be average product. It rises and then it falls. Now the marginal product does the same thing, only it is steeper typically. Okay, so in other words, what you might expect to see is something like this. Now, you notice they start at the same point, and then the MP rises very rapidly, and then suddenly it starts to fall off very rapidly. And at the intersection point, MP equals AP, where APL reaches its maximum value. All right, so that's and the typical shape, and then MPL eventually becomes negative. The average product cannot be negative because the total product can't be negative, but the marginal product can be negative. And if you can see, as you keep increasing your output, eventually you will reach that point. So this is a pretty good representation, I think, of the average and marginal products of labor. All right, so why don't we, now I did draw these. Now in Excel, I have the actual graphs. This is what they look like in Excel. You'll see it's very, very similar. Yeah, it's, Excel's graphs are okay. It's not that bad, but you get the idea. And of course, you can see here that they start together. They cross at the maximum value of APL, roughly, and a marginal product does eventually become negative. So it looks very much like what I did by hand up here. All right, so try to, when you draw your picture, try to keep it roughly like this one. It doesn't have to be a masterpiece, but it should have this same basic setup. Okay, so I'll give you a minute to catch up to that. All right. So also what we can do, in the video they did this, maybe we could try this ourselves to try to get a rough idea of how this compares with the total product curve. Let's see what I can do here. This isn't that easy to draw, but let me try it. So right about here is where diminishing return sets in, because the slope is going from, the output is increasing at an increasing rate, and then it is increasing at a decreasing rate until we peak out right about here. So we've got these three sections, which we saw earlier, but where do they correspond to these two curves? Okay, so what I'm aiming for is the average product should peak out right about here. And then the marginal product should look like this. It goes up, it comes down. All right, and then this is where it crosses and becomes negative, where the curve on top peaks out. Once you get past that point, the marginal product actually becomes negative. So on the top, keep in mind in this region in the middle here, output increases at a decreasing rate. And that's where the average product and marginal product should be falling. Over here, output increases at an increasing rate. And so that's why both of these are rising. And then finally over here, output is decreasing. And so that's why the marginal product is negative. All right, so yeah, I mean, I got a little crowded there, but the idea is that it would be nice to be able to see all three of these curves together in one place so you can see how they're related to each other. All right, now, let's see. So, law of diminishing returns, we've already seen that. We've already seen that the curve shifts up with technological progress, okay. The cost of production, okay. Now, this is sort of the other side of the coin of production, the costs, okay. In other words, up to this point, we've been focusing on how much output we can produce. Now the focus is on how much does it cost to produce our output. So we're still considering ourselves to be in the short run. And that means labor is the only variable resource. The others are fixed. And so as they said in the video, there's really two basic kinds of costs that we might encounter. Well, all right, let me, oh, no, well, this is already it right here. Let me add this extra sentence here. This means that labor costs are variable and that the costs of all other resources are fixed. Now, what does that even mean? Let me just give you an example of this. So this is sort of like a taste of what's to come. Variable costs increase when more output is produced. For example, in order to make more beer, we must hire, or we must pay higher wage or more wages. Okay, so wages are a variable cost. All right, so in other words, we can't make more beer without hiring more people, which means the labor or wages are going to go up. Fixed costs, on the other hand, do not change no matter how much output we produce. And that's why they're called fixed. In other words, we have to pay a certain amount of money to run this business, regardless of how much labor we have. So let's say for the microbrewery, fixed costs do not change when output changes. For the microbrewery, the cost of the equipment that was purchased is a fixed cost because it never changed. It doesn't change when more output is produced. Okay. In other words, if you've ever seen a microbrewery, there's a ton of equipment that they need. It's a very, very expensive process. There's all kinds of equipment that they need. And once they've bought it, though, that's it. They don't have to pay for it. It's done. They own all that equipment, and they can, the cost of the equipment is the same whether they make 1 gallon of beer or 1,000. It doesn't matter. That's a fixed cost. It has to be paid. But once it is paid, we never have to worry about it again. Just like in the video, remember he mentioned the pizza example. Once we own that pizza oven, it doesn't matter how many pizzas we make. That part of it is done. It's fixed. We don't have to worry about that. But we do have to pay extra for cheese and tomatoes and labor too for every pizza that we produce. So the pizza oven is the fixed cost, and the cheese and the tomatoes and all the rest of the dough, those represent the variable costs. So virtually all business enterprises have both variable and fixed costs. It's hard to imagine a scenario where there isn't at least some of each. Now, having said that, in some businesses, let me add this as another explanatory note. Each industry, or the proportion of variable and fixed costs is likely to vary by industry. For example, in a capital-intensive industry, such as steel manufacturing, much of the work is based on physical equipment. And so there will be a high percentage of fixed costs and a low percentage of variable costs. Or here's another good example. I just happened to catch this on TV the other night. I think you'll find this interesting. I was watching a video, not a video, a TV show. And in this episode, it's called Modern Marvels. Okay. And it's about technology. But in this particular episode, they chose to focus on Wise potato chips and, their factory where they make the potato chips. So you might figure, well, you go in the door, you might expect to see people sitting there peeling potatoes and salting the potato chips and, frying them and all this and that. No, actually, almost all of the work is being done by machines. Almost all of it. It's extremely highly automated. Almost none of the actual work is done by human beings. So in an industry like potato chip making, the fixed costs would be extremely high. It would be like almost all of the costs are fixed costs because of the requirement of all that equipment. If they don't use all that equipment, then there's no way they could compete because the costs would be so much higher. The machines are insanely efficient. So in an industry like that, the only way to survive is to have a lot of machinery, and that means a lot of fixed costs. On the other hand, suppose we had an industry like software. Most of the work is done by software engineers, let's say, or computer programmers. Okay. The capital equipment is limited to computers. I mean, everybody has to have a computer. So therefore, most of the expense of producing software comes from labor, so that a very large percentage of costs are variable costs. All right. So in other words, here you've got a situation where they don't have a whole lot of equipment. All they really need is everybody gets a computer. That's it. There's nothing else they need. Everybody sits down and they write programs all day long. And then whatever they produce, they sell it to the public. So here, the majority of the work is being done by human beings. And of course, that means we have to pay them wages. And so those wages are variable, since the amount of software that we produce depends on how much labor we use. So in an industry like this, the vast majority of the expenses are variable. Whereas with the steel or the potato chips, most of the costs are fixed. So while they both have some of each, you can see that the mixture is very different from one case to the next. Okay, so that's just something to be aware of. And we'll see later on that affects their long-term cost of production. How much of it is variable, how much of it is fixed. So anyway, but for our purposes here, it's just enough to know that there are two basic types of costs, fixed and variable, and each industry has a different mixture of fixed and variable costs. Anyway, with all that being said, we can also categorize costs in two additional ways. They can all be defined as either implicit or explicit. And you'll see in a minute that this is getting back to the idea of opportunity costs. Okay, so explicit means basically money that we're paying to obtain a resource. Implicit refers to opportunity costs. Okay, so let's go through that one at a time. So explicit costs are actual expenditures that the firm has to make to acquire resources, land, labor, and capital. So if you write a check to pay for something, it's an explicit cost. And of course, we have lots of those. As we saw earlier, they can be subdivided into variable and fixed. Both variable and fixed costs are explicit because they're coming out of our pockets. But what about the implicit costs? Well, we've already discussed opportunity costs. What is this all about? So what if we are, let's say Intel. Intel is a major manufacturer of computer chips. Suppose that they own the building that they're using to make those chips. And if they chose to stop making chips, they could rent the building out to somebody else for $1 million a year. Well, if that's the case, then the opportunity cost of running this business would be $1 million a year, because they're sacrificing the opportunity to make or earn that rent by making chips instead. So is this important? Of course it is, because it helps determine if they should be making this product at all, or how much profit they need to make to justify it. So, a lot of times when companies go bankrupt, it's not because they have no money. It's because whatever it is they're doing is not enough to justify the opportunity costs. So instead, like in a case like this, if for whatever reason the computer chips weren't making a lot of money, they might be better off just closing the doors and just renting the building. Okay, so of course, we've already seen before, implicit costs are known as opportunity costs. In this example with the building, we're not actually writing a check to somebody for $1 million, but we are sacrificing the ability to earn those $1 million. Therefore, it is a true cost, although we call it an implicit cost. All right, so these opportunity costs show up everywhere, don't they? Yes, they do. In fact, everything we do ultimately involves opportunity costs because our resources are limited. It's just as simple as that. Even if it's just our time, every time you decide to do something with your time, you're sacrificing the ability to do something else. That's an opportunity cost. All right, now, with all that being said, we're going to finally bring together some cost functions, which will be based on our classification earlier that costs are either variable or fixed. So we're going to introduce what we will call total costs. And you can see that they're simply defined as total fixed costs, total variable cost, and total cost, which itself is simply equal to TFC plus TVC. All right. So how are these? Oh, and by the way, if you recall, when we're looking at production, we had total product, we had average product, and we had fixed product. I'm sorry, marginal product. What am I saying? Total product, average product, and marginal product. We're going to see something very similar here. Since we have total cost functions, that means we'll also be able to define average costs and marginal costs. So let's take a look at these for a second. Okay, there they are. So here's the rest of them. So corresponding to these three total costs, we have three different types of average costs and one type of marginal costs. This, by the way, specifically refers to total costs, but we'll see how that works in a minute. Marginal. So we have three averages, one marginal, three totals, three averages, and one marginal cost. All right, so that's 7. That's a lot to keep track of, but it turns out that not all of these are equally important. So it won't, after we've analyzed them all or introduced them all, we'll see that there's a few that are especially important. All right, so I'll give you a minute to catch up. All right, well, the total costs are, I think, pretty self-explanatory. So let's start with total fixed costs. So these are the fixed costs. These are the ones that we have to pay for no matter how much output is actually produced. So with the microbrewery, we have to pay for the equipment, and that's going to be the same no matter how much beer we actually make. All right, so these are the ones, and it's more than just the equipment. I mean, there's other things we may have to, for example, pay property taxes on the building that we're working in. And there's all kinds of potential fixed costs, but what they all have in common is that they don't change when we produce more output. All right, well, then you can probably figure out what's coming next. How about total? Oh, here's a good example. In the case of a Starbucks, fixed costs would include all the machines that they have in that building. They have coffee grinders, they have espresso machines, they have blenders. Those they have to pay for, And even if they sit there idle all day long, or if they sell or using them continuously, it doesn't matter. The costs are fixed at whatever we paid for these machines. Then we have the variable costs, which are the ones that do change when output increases. So since we're talking about Starbucks, we can easily visualize what kinds of costs are variable at a Starbucks. Like what? What would they have to buy more of to sell more coffee? Well, how about coffee beans? Can they sell more coffee without buying more coffee beans? Of course not. That's the most important part of their product. Oh, and of course, there's more than that. For example, how about milk? Most of the drinks that you buy in a Starbucks do have some milk in there, even if it's been steamed. That's right. The labor itself is variable. So we'll add to this labor, wages. So you've got the coffee beans, you've got the milk, and of course wages. In order to produce more output, you have to have people work more hours. Okay, so, and I'm sure you can think of others like sugar. I'm sure people use a lot of their sugar. The cups, that's right, the cups. Don't forget about the cups. Do they make you bring the cups back when you buy a Starbucks? No, you get to keep it. That means they have to pay for it. I actually saw, I was watching a show once about people looking for a new home in Germany. No, it was either Germany or Austria. And they went to a coffee place and they figured, well, they'll give us paper cups and we'll throw them away. No, they gave them actual cups and they were expected to bring them back. I was a little surprised to see that. I guess they're on the honor system over there. All right, but anyway, so there's all kinds of variable costs that they have to pay for in order to sell more units of coffee. Okay, and then finally, we can bring all these together and just note that the total cost is nothing but the sum of the total fixed and total variable costs. All right, now, so because we're running out of time, we'll have to save the other costs for next time. But in addition to these calculations, we also are going to introduce curves for each one of these. And we're going to need to pay very close attention to these cost curves because we'll continue to use them throughout the rest of the course as we analyze different types of markets and different types of business organizations. These will prove to be extremely important in helping us understand how these different types of businesses maximize their profits. So rather than rushing through the rest of this, we only got a couple of minutes. Why don't we stop right here? And then I actually do have a couple of good videos that will help reinforce what we just did. So we'll save those for Friday. That's right. Today's Tuesday, isn't it? So Friday, we'll get back to this discussion. We'll do some calculations, draw some curves, and then we'll have a couple of videos to help tie all of this together. Oh, well, I don't want to guarantee you anything, but you can probably imagine that it takes a long time to grade all this stuff. So soon, yes, in the sense that it probably will take several more days, but not several more weeks. Let's put it that way. Most likely, I will probably need to finish them over the weekend. Realistically, I mean, it's possible that they'll be done sooner, but I would say it's probably going to have to wait until the weekend to be completely done. So I know it's annoying, but yeah, sorry about that. I want to do a good job with them, and I don't want to rush through them. So anyway, so all right. Other than that, I guess we're done for today, and I'll see you all next time. You're welcome, everyone.